The purpose of this presentation is to identify several options for remedying low sensitivity detections in Odyssey Western Blots. In most cases, sensitivity issues can be resolved by altering a few software settings. However, in more difficult cases, it is necessary to take a look at the chemistry of the assay. There are several opportunities within the Odyssey software to adjust the image display. These adjustments only affect the visual display and do not alter the raw data associated with the image. Image display adjustment options include changing the linear auto setting to linear manual, adjusting the brightness and contrast of the image, and altering the background settings. If alterations of the image display do not satisfactorily improve your image, it may be beneficial to stop and examine the chemistry of the assay. Consider changing the secondary antibody dilution factors, experimenting with different blocking buffers, verifying the primary antibody performance, or labeling an enhanced chemiluminescence secondary with a near-infrared fluorophore. We will discuss all of these options in more detail, but we recommend troubleshooting with the software analysis settings first. There are three common problems that can be corrected with a few tweaks of the Odyssey software settings. These include blots that are showing no fluorescence, dim bands, or background. Keep in mind that these software enhancements will only work on blots that are not experiencing binding chemistry problems, an issue we will address later. Blots that unexpectedly exhibit no fluorescence can be enhanced by changing the sensitivity setting of the image from linear auto to linear manual. Open the Alter Image Display menu by clicking the icon highlighted in the toolbar. Notice here that linear auto is checked for both the 700 and 800 nanometer channels. This option allows the software to determine the best fit of all pixels within the image. For blots with a wide range of fluorescence, this may not be the best option. To enhance the image, simply click the Linear Manual radio button and adjust the slider. By manually managing the sensitivity settings, the most desirable image can be chosen. Improving the appearance of dim bands is as simple as adjusting the brightness and contrast of the image. These settings can be changed from the Alter Image Display menu as well. The default software setting, shown here, is 50. Adjust the brightness and contrast sliders to brighten and darken the pixels until you are satisfied. Each channel can be adjusted independently. Image adjustments also can be made in grayscale. Very faint bands can be visualized better in gray. There is a feature within the Odyssey software that should be used every time a blot is quantified. The background method sets the background calculation method for use in quantification. It averages the intensity of the pixels selected as the background region. The background method window can be accessed via the toolbar. See the highlighted icon. There are several different methods for background subtraction, each unique to a specific need. The first method of background subtraction available is the no background method. In this method, 0 is used for the background calculations. This is the best choice for assays with their own background calculation methods, such as concentration standards used with in-cell Westerns. The no background method is rarely used for Western blotting purposes. The second method is average. This method takes the average value of the pixels on all four sides of the feature, or in this case, the yellow rectangle. It is possible to choose the number of pixels to include in the calculation by changing the border width option. The third method is the median function. This method sets the background level to the median value of the pixels outside the feature. You may select which sides of the yellow rectangle to include, all, top bottom, or right left. This feature is also available with the average background method. The last method is the user-defined method. This method averages the intensity of pixels enclosed by a selected feature. To implement this method, display both image channels, draw a feature over an area of typical background, be sure not to include any hot pixels, select the feature, choose the background icon from the toolbar, and change the background method to user-defined. Click Save and OK to the message. Notice that the regular feature has now changed to a background feature. This method is not preferred over average or median due to possible inconsistencies in noise across the image. When choosing which background method is most appropriate for a blot, make a decision based on the amount of fluorescence around the border of the features drawn. If the pixels just outside the feature are dark background pixels, then all boundaries will produce good results. However, if there are bands that are vertically or horizontally close together, it is best not to use the top-bottom or left-right segments respectively in the background calculation. In cases where there is a lot of fluorescence surrounding the feature of interest, use the user-defined calculation method. Whichever method is chosen for calculation will be used for both the 700 nanometer and 800 nanometer channels. It is important to choose an appropriate method for background calculation whenever you are doing quantification. If none of these suggestions seem to be improving the visual quality of the Westerns, then it may be advantageous to look at the assay chemistry. If the background of a Western blot is high, it will affect the signal-to-noise ratio so that in some cases bands may appear weak or absent. This increased background can be corrected in a few ways, but most common is to reduce the concentration of the secondary antibody. We recommend using a starting secondary dilution factor of 1 to 15,000. Many of our users discover that they can dilute even more than this and still produce satisfactory results. Choice of blocking buffer is another consideration when reducing background. Some blocking buffers are more effective for some antibodies than others. In these Western blots, PKC alpha has been detected in cell lysates using 3 different blockers: 5% BSA, 5% milk, and Odyssey blocking buffer. The non-specific binding is greatly reduced when a more appropriate blocker is used. While the Odyssey blocking buffer was a better choice in this example, no single blocking reagent will work for all antibodies. Try different blockers to determine what works best for your target protein. If your target antibody has previously worked with ECL, you should use that blocker first. If running standard ECL Westerns, try obtaining an unlabeled version of the enzyme conjugated secondary, which in this case would be the orange portion of the secondary antibody, then label it with a near-infrared fluorophore using an IR dye labeling kit. We can expect similar binding patterns from the fluorescent blot because the binding portion of the now near-infrared secondary is the same as the chemiluminescent secondary from before. Remember, if using a labeling kit, make sure the ECL antibody does not contain BSA or other proteinaceous stabilizers because they will not label well. Remember, if the HRP conjugated primary was working fine for chemiluminescent detection and is not working for Odyssey detection, the recommended first step is to try the Western using the blocking buffer that worked for chemiluminescent detection. For further assistance, please contact LICOR Technical Support at 800-645-4260 or email biohelp@licor.com. Your area field application scientists also will be willing to help.